Good evening. I'm Aida from Arabic Police. We are on a groundbreaking exploration to explore the complex interaction between the Arctic Ocean beneath the sea ice. Over the next few minutes, you'll meet our scientific leads who will explain how physical, chemical, and biological processes are connected in this fragile region. Now, let's dive into explore how sea ice chemistry influences greenhouse gases and atmospheric compounds in the Arctic.
Hi, I'm Zanti and I study atmospheric interaction in the Arctic Ocean. So sea ice is actually quite complex. Carbon dioxide from the atmosphere can dissolve and accumulate as dissolved inorganic carbon, which ice algae use for growth. But that's not all. Methane, another greenhouse gas, which can escape from under the ice, sometimes from microbes or thawing permafrost along the coast, which that makes sea ice both a carbon sink and a potential greenhouse source. Not only that, snow and sea ice also release reactive halogens like bromine, chlorine, and iodine. So these halogens get into the atmosphere through two main processes, which is from snow surface, and the other one is salty wind-blown snow. So these halogens can change atmospheric gas chemistry, especially during the springs. And as ice melts, biological activities increases, especially from the phytoplankton. So they produce gases like dimethyl sulfide or DMS, which come from clouds and affect the climates. So even the smallest organisms under the ice are part of the bigger atmospheric interactions.
Next, we head to Nobel, who studies what's locked inside the sea ice itself.
Hi, my name is Nobel, and I'm the professional marine scientist that specializes in Arctic sea ice. But sea ice is not just simple frozen water, it's a dynamic living system, as it forms brine channels that trap salt, gases, nutrients, and even microbial communities. These brine pockets create unique microhabitats, allowing bacteria, algae, and tiny animals to thrive within the ice. And when the sea ice grows, it expels the brown downwards, increasing salinity and altering the density of surrounding seawater, which can influence the ocean circulation as well. And during melting, the ice releases stored nutrients like nitrate, phosphate, and also silicate into the surface ocean. And this seasonal nutrient boosts phytoplankton bloom, especially in the spring, forming the base of the Arctic marine food web. Sea ice also moderates gas exchange, affecting carbon dioxide uptake and playing a key role in the global carbon cycle.
Let's go to Fadila for a look at what's happening with carbon and nutrients.
Hi, I'm Fadila. I study carbon and nutrient cycle in the Arctic. As the seasons shift and ice melts during the spring and summer, the nutrient-rich brine drains through vertical channels into the underlying water column, and this phenomena promotes phytoplankton blooms. Algal excretion, grazing or cell death sink to the ocean floor in the form of particulate or dissolved organic matter. And on the seabed, the microbial remineralization occurs where heterotrophic microbes decompose these materials and convert it into inorganic nutrients like ammonium phosphate and also carbon dioxide. And together, this interconnected process drive carbon and nutrient cycling in the Arctic Ocean. They not only support marine ecosystem productivity but also contribute to the global carbon regulation through the biological pump.
Let's not forget the life forms under the ice. What organisms thrive in this cold ecosystem?
Hi, I am Atira and I study biological productivity in the Arctic oceans. It might surprise you, but beneath the sea ice lies a vibrant ecosystem just waiting to come alive. As the ice melts in spring and summer, sunlight reaches the surface water, triggering blooms of phytoplankton. These blooms support the entire chain of life, from tiny zooplankton to fish and even majestic whales. But phytoplanktons do more than feed the Arctic through photosynthesis. They absorb carbon dioxide from the atmosphere, playing a crucial role in regulating Earth's climate. Their growth depends on two key factors, light and nutrients. If the ice doesn't melt enough or if ocean mixing is too weak to bring nutrients to the surface, productivity declines. That's why changes in sea ice and ocean dynamics can have major biological consequences. The Arctic may seem remote, but its productivity links life, carbon, and climate on a global scale.
Let's check news Niji, who will be observing waters in the country.
Hi, I'm Minji, the expert in physical oceanography. Physical processes also play a crucial role in shaping the biogeochemistry of the Arctic sea ice ecosystem. One of the most significant processes is sea ice formation and melting. Did you know 40% of Arctic sea ice is seasonal? thereby freezing and associated brain drainage, greatly modify the salinity, gradient, and vertical mixing, regulating the availability of nutrients and dissolved gases like carbon dioxide for ice, algae, and melt cone communities. On the other hand, melt cones and sludge layers form on the surface as the ice melts, allowing light transmission for organisms beneath the ice, promoting photosynthesis by sympagetic algae and other ice phytoplankton. Additionally, mixing and remineralization of water layers, which is driven by ocean currents or temperature gradients, further impact on the vertical distribution of nutrients and gases, thus controlling the timing and extent of phytoplankton groups.
To wrap up our journey, let's welcome Shaz with the key takeaway.
Thanks, Anish. I'm Shaz, the head of Arctic Expedition. The Arctic is a small region with a big role. Everything from air temperature to mixing currents affect how carbon is stored or released. It's a system imbalance, and as the ice melts, that balance is shifting. What you see here is give us insight into the climate change and how it might unfold globally. Small changes can affect the world Arctic ecosystems. The air, the ice, and also the oceans also exchange gases like carbon dioxide and methane will affect our atmosphere and climate. By reforming temperature, these natural resources are being disturbed. Ice is melting faster, bloom patterns are shifting, and the food web is at risk. That's why our research is important. By understanding how the Arctic works, we can protect it and help protect our planet.
Thank you for joining our expedition. Remember, what happens in the Arctic doesn't stay in the Arctic. Stay curious and keep exploring.